Sibiski. My teammates are Juan, Aguilar and Azcue. We are advised by Dr. Tosunoglu and Dr. Jansel, and I will be discussing a few issues with electricity, and I'm going to fix them. Electricity is used for a wide variety of different applications, such as heating, cooking, lighting, and also to power various devices in developed countries. However, about 1 billion people in the world are still living without electricity. Countries that are living off-grid, in comparison to the U.S., may not have access to electricity unless they have their own electrical system. And also, even in developed countries that have electrical grids, this electricity cannot be accessed everywhere. For example, people cooking or camping, or those at the beach who wish to charge their devices or listen to music, and other examples. In order to fix that, we would like to develop a product. So our product will be a multi-source energy harvesting device. So we would like to take advantage of wind energy and also solar energy. The portability of this product is key to allow for hikers, people traveling to music festivals, leisure activities, can take this product with them, and they can use it for a wide variety of applications. So we plan on having rechargeable batteries within the system, and these batteries can be used to power speakers, lights, jumper cables, and also built into the device will be USB outlets and various voltage outlets to operate various devices. Also, the product must be weather resistant to operate in a wide variety of conditions to ensure that we're reaching a very wide audience. So currently there are various recharging devices, however, the majority of them are single source. So they have solar recharging devices, and also Trinity, a product called the Trinity 400 is a current portable wind turbine in its early stages of development. However, it's very hard to assemble, and its charge time is relatively slow in comparison to other cores. Like I said, these devices are single source, so by taking advantage of multi-sources of energy, we plan to achieve a higher capacity in the same or a shorter amount of time. So the capacity we wish to reach is 70,000 plus milliamps, and we would like to achieve this by 3 to 4 hours. And our goal is to have 70% of energy harvested by the wind and 30% by solar energy. The product should be 24 inches in height, and the lifespan should be 10 to 12 years, assuming that our batteries are up to par. And operating temperatures cannot fall below 32 degrees or rise above 113 degrees Fahrenheit, otherwise the battery will have issues.
Right. This is a simple system diagram. As you can see, this is the major components that will be involved in our design. We have the wind turbine and the solar panel will be sending the power to the power controller. The power controller will be in charge of controlling the charge to the battery and the voltage spikes. Also will be in charge of monitoring the state of charge of the battery. Once the battery has reached 100%, it will send charge to the battery. Also, since we have different loads, we will have a converter that will supply with 5 volts, 12 volts, and 24 volts for all the loads that we'll be using. As of right now, we have 2 design ideas. One is a horizontal and a vertical. For the horizontal idea, we will have portable plates and the solar panels around the body. The advantage of this design is that we'll be able to fold the plates into the device, so whenever you're traveling or carrying around, the device will not suffer any physical damage. The disadvantage is that we will have to turn the axis of the device so catch the wind, like depending on the direction of the wind. For a vertical design, on the first one we have the solar panels built into the plates, and the generator batteries and controller will be at the base. For the second one, we will have the plates on top and the body in the middle with the solar panels on top. And for the last design, it's more like a concept. We will have the body in the center, the plates around it, and the solar panel on top. The advantage of this system is that we catch the wind from every direction, so you will not have to like anything turning. The disadvantage, it will be a really big design, so to travel and carry around will be very difficult. since we have a turbine agreement, we have to perform a mechanical simulation to make sure that all components work with each other and they will not interfere with one another. Also, electrical simulation will be performed for the charging system, make sure that there's no overloads to the batteries. Also, since we have wind forces acting on the device, we will perform force and stress analysis. As AJ said, the device will be used in different climate conditions, so a thermal analysis will be performed. And also, since we have a rotary system, a dynamic and vibration analysis performed, so it will be in perfect balance. These are some of the standards that we'll be using. The ANSI for gearbox for wind turbines, the IEC for small wind turbines, and the IEC for power performing electricity producing wind turbines.
And so here we see a cost analysis and the estimated cost of all the related parts that will make up our wind turbine. You can see, for example, gearbox, and the more expensive things on here are things that we cannot manufacture ourselves. For example, a controller, solar panels, and a generator. Those are things that would be very difficult for us to manufacture, and so they're the highest priced items on the list. Things like gearbox, we can CNC ourselves. Body, we can 3D print ourselves. Legs and hinges are also things that we can 3D print or manufacture ourselves. And so that was the materials cost and just labor cost that would be us. We have miscellaneous here, it's $50, and that would include wiring, electrical tape, all the other components that are secondary in the system. And right now we have an estimated total of $172. If we were to take this product commercially, we're hoping to price it in the $300 to $400 price range to be competitive with, for example, the Trinity we showed earlier. The retail cost for that is estimated to be around $400 when it does reach the commercial phase, and so we're trying to keep that in mind to keep costs as low as possible. Here's our project timeline. As you can see, we spent this semester working on conceptual designs, picking between vertical and horizontal, trying to do some simulations in SolidWorks, seeing what gives us better speed. Also, we have to think about portability. So, as you saw, the horizontal wind turbine has the benefits of taking wind from any direction, but it was a little bulkier. So, we're trying to come up with some mechanical systems where maybe the blades can fold there, the legs are telescopic so they can slide in. Things like that will help keep it portable, and so that was all conceptual design and turbine design. Now we're moving into gearbox design, and over summer we're going to be designing a lot of these things, and hopefully by the end of summer, beginning of next semester, we'll be putting all the systems together to make sure they would work well together. We'll start actually testing the prototype next semester, and optimization will be towards the end of the semester, and so we can have a nice finished product towards the end of the year. This is the distribution of our tasks again. AJ here in charge of structural design, component design, physical calculations, and helping with assembly and disassembly. Myself worked on turbine design, gearbox design, electrical calculations, and power generation for this device. And Nelson here worked on solar panel design, the electrical calculations mostly, power generation, and charging system on the electrical components. So for global design, we hope to have a user manual in three different languages: French, Spanish, and English, to reach as many people as we can. Also, we hope to put warning symbols on the product so it can be understood anywhere in the world, no matter what language you speak. There's a symbol that says "Don't put your hand here." It's pretty understandable. Also, for assembly and disassembly, just so there's no conflict with language in case you can't understand any of the languages the manual is written in, we hope to have very well illustrated instructions on how to assemble and disassemble in the user manual as well. So in conclusion, we're hoping to create a multi-source energy harvesting device that can be portable, taken anywhere to address the issues of the billion people in the world that don't have access to electricity, or also maybe you do have access to electricity, but you would like to take this to the beach or camping during leisure activities, somewhere you will be isolated from electricity, as well as emergencies in case there's a big storm or a hurricane. your power goes out at your house. It's okay to go outside, set this thing up in your yard, maybe have a little bit of charge to charge your phone, call relatives, maybe cook a little bit at night. So this is definitely very beneficial in an emergency situation like that. All right, thank you. Are there any questions?
Yeah, you always ask my questions, so I'm gonna...
I'll let you go first this time.
So, it says portable, but 20 pounds is pretty heavy to take around everywhere, you know? So, is there a way to lower that weight?
So currently, in order to reach
Was it?
in order to reach our capacity, we were going to utilize multiple batteries. But in order to make it lighter weight, we may have to invest in a more expensive battery that will be lighter weight.
Yeah, I think that's important if you're gonna make it portable. Also, assuming there's no wind power, what would be the difference of charging it just with solar power? What's the benefit? I mean, did you do calculation on how much power you get from the wind at peak? 10 miles per hour as opposed to 0 miles per hour, and see what the difference is? Did you guys figure that out?
We haven't carried those calculations out. We plan on having 70% from wind and 30% from solar. However, solar panels could be pricey. Currently, we were going to implement a cheaper solar panel, but if we aren't able to achieve these wind goals, we may have to invest in a more expensive solar panel to offset this. So, in order to achieve like a higher wind power, that's why we're mainly aiming for the horizontal configuration, so that it can capture wind from any direction. So even if it's a low wind speed, it'll be constantly moving.
But if you have a vane on or something on the other one that's vertical, or horizontal, I'm confused now. Wouldn't it line up with the wind?
Yes.
I think from the things we've seen, if a vane isn't always as reliable, just because you're going to have that turning motion and like the way the generator is going to be positioned, it just adds more complications than if it's just horizontal and it's always going to run.
My question is around packaging. I go to the beach, I carry an umbrella, I carry 2 chairs. How am I going to hold this beast? Or are you going to design something that gives me the ability to throw it over my shoulder? When I'm going camping, I've got a backpack. I throw a backpack on my back. This thing needs to be able to be connected to the frame of my backpack, let's say, so that I have the ability to carry it into where we want to go. And it also has to be idiot-proof from the standpoint of hitting things, knocking it down, dropping it, because I will do that. And the next thing I know, I try to pop it up and it doesn't function. So I'd like to make sure that when you do your design, you assume that the average human being is going to use it, and you incorporate those type things into the design.
You'll get sand in the bearings.
I think you need to look more at your target market, because if you're talking about third world countries, it's way too expensive, if that's what you're going to do. If you're going to sell it in Dick's and West Marine, not so much. So you need to look at that, where your marketplace is going to go, and then design something that the economic cost is going to match the ability to somebody to walk in West Marine or Dick's and pay the money that you're going to get for it. Certainly the way you've got it right now, you couldn't take this to a third world country or the African continent and try to use it for something. It's just way too expensive.
Well, my question is, how many other portable solar wind turbines are out there right now?
So currently there is one portable wind turbine. There aren't any portable multi-source devices, but there is this Trinity, which is
That's
still...
the only one?
Pardon? Yeah.
That's the only one?
And it's not manufactured yet commercially, so they're still in their development stages.
And what's the major difference between their design and your design?
So we wish to reach a higher capacity. There's, I think it's 50,000 milliamps, or 30,000 milliamps, and we wish to reach 70,000 plus. And because we're using multi-sources, hopefully we can achieve this higher capacity in the same amount of time or less. So that's kind of our... And because we're having a higher battery output, our device can actually be used to jumpstart a car or other emergency situations, whereas the Trinity is used to charge an iPhone 6 times different.
You said the Trinity's cost is $400 roughly, and you're even for what, between 300 and 400 is what you said?
I guess one last question. Are you intending to do any simulation modeling of wind flow through this system to make sure it doesn't go tumbling down the beach?
And that's why, so for the legs, we hope to have them almost like stakes. So if you're at the beach, you can stake it into the sand, or also if you're on a hill, you can stake it into some type of dirt or something to maintain the stability.
So I'll start with the legs since you bring that up. I would first look at what market, as Alan mentioned, if it's for the camping person, then you might want to look at legs that can be adjusted. You're not always on a flat surface. Something like a camera stand design. Second, to the weight and the cost point of view. Right now, it's cheap, probably for me cheaper and less weight, less impact to weight. I just go and buy 20 packs of the cell phone battery chargers. So what are you bringing to the table that makes a difference between me just buying batteries or even bringing a car battery with me than having this? Also, I would like to see more about your airfoil design. Right now I only see 3 different airfoils there. The less airfoils you have, the less efficient your system's going to be. As far as protection, you have your airfoil sticking out, so chip drops this, and now you're dinging up your airfoils, which is again going to make your system less efficient. Your bearings, the gentleman over there mentioned, you need to see how you are going to encase the bearings, what kind of bearings you're going to use. If you start taking it into adverse weather, into the beach, you're going to start seizing up those bearings, and now your wind turbine doesn't work. And I would look into your efficiency measurement, as well as your power. You're saying you want to do 70% wind and 30% solar, but maybe a better way of translating that is looking at your optimum versus your adverse scenarios. If I have great wind, great sun that day, how long is it going to take me to charge the battery versus it's a cloudy day, no wind or very low wind. That way you have a range. You can say this machine can charge up a phone in 2 to 8 hours, depending on what kind of weather you have.
You might think about safety from the turbine, as I'm looking there, thinking about my 4-year-old granddaughter who thinks it's really cool that it's a very windy day and it's going around at 600 RPM, she sticks her hand in. Or my favorite parakeet flies into it, you know. Something you're going to have to cage that somehow if you're going to have it low enough where people can stick their hands in it.
Quick comment. Guys, when I read your title, Portable Solar Wind Turbine, I was expecting a turbine capable to work using wind and solar at the same time. Maybe what you guys have here is a portable solar wind system. Having said that, obviously you have heard the comments, weight is a major constraint. So think about maybe going back to the solar wind turbine, your winds, either a horizontal configuration or vertical configuration, your winds could have this new flexible solar panel. So your blades, back and front, could have solar panels ready, okay? So you can avoid the solar panel by itself, which is a problem to deploy it, weight, and all the stuff. So if you go back to the solar wind turbine, it could be only just a turbine using wind and solar at the same time. See what I mean? Okay, so that could be an optimizing step taking into account that, okay? Because solar panels and themselves and batteries are always a problem for the weight, the final weight of this type of system, okay?
One last observation, I would like to see a pre-buying diagram of this. Your design seems very top-heavy, which again, if you're not in a flat surface and you have somebody holding it down, this could just tumble. So,
Also very clean. That's where the wind is.
So as far as the percentages go, I stepped out for a minute. So you did that as a goal under perfect conditions. We talked about that before, right? That was the expectation. So